Okay. So, again, Assalamualaikum and good afternoon, class. So, this week we're going to look into chapter 3 of our textbook, which are topics on systems, linearity, and time invariance. Okay. And most of our class today will touch on the systems and its properties, classification, interconnections. In the next class, we'll go deeper on the linear time invariant system, or LTI. Okay, so what is a system? Previously, we learned about, I think I make it larger. Okay, so previously we learned about signals, and now let us look at a system. So what is a system? So this is the definition of a system. A system is defined as a combination of components or elements that act together to perform a certain objective. Yes, so this is a definition of a system. It contains interacting components to get connected together in which the variation in one component affect the other components. Is there still attendance? Yes. The component is usually a single functioning unit of a system. Oh, ada lagi. For example, let us look at figure 1 here. So I adopted it from this reference. This is example of the vehicle's energy regenerative suspension system. So this is it. It's an inside the car or automotive. So in this system, we have components or elements. For example, like here, we have one on energy harvesting. So meaning that this system is having how to convert motion into energy, yeah? And then a motion, rectifier, and then a generator, and so forth. So these components, usually it is a single functioning unit of a system, and it has its own input and output. So all these components interconnected, and it becomes one system. In this case, vehicles energy regenerative suspension system. So this is the definition of the system. Okay. So if you look here, this what is a system? This is a representation. For example, we have a set of inputs and then map into to produce a set of output. So in terms of a block diagram representations, if you look here, we have an input, we have the system, and usually the system is defined by a mathematical equations. And then we have the output. So the input and output space may be continuous or discrete, and these sets are also may be finite or infinite, bounded or unbounded. So these are the things that we're going to look into. And the mapping usually either one-to-one, or maybe a one to many, or many to one, the mapping. So maybe it is interconnected to one another, maybe it's directly one to one. Okay, and it may be deterministic or probabilistic, with or without memories. And based on these aspects, systems are classified into several different ways, of which we're going to look into in the next slide. Okay, there are many categories or inputs and outputs of our inputs and outputs. If we look here, um, the MIMO system, or the full definition of MIMO is multi-input, multi-output. So if you look into the block diagram here, for example, like we have two inputs and two outputs, and this input may be one-to-one mapping or one-to-many mapping. So this is called MIMO system. And then another one is single input and single output, where we have one input to produce one output. So this course of books the textbooks deals with single input, single output or CISO system. And usually we represent the input as U and the output as YT, are function of time, and sometimes XT. So this input and output are function of time. Okay. So far so good, class?
Yes, doctor.
Okay. So this is a definition and example. What is a system? If you look at figure 3.10, this is elements of a public address system. So the system here is a public address system. So the meaningful interconnection of physical devices and components, as what we defined just now, is called a system. So in this case, most of the system is single. The components of the system is single input output system, and overall the system input is the microphone and the output is the speaker. So if just now, as we said, it is the whole system consists of elements or components. So let us look one by one in this example. The first one, bear in mind our input is a microphone, and then this microphone will go into element one or the subsystem one. So this is the microphone. It will convert the incoming sound to electrical system, and this electrical system will be in the input for subcomponent 2, which is a voltage amplifier, which will amplify just now initially the sound converted into electrical, which is in this case voltage. So these two will amplify the voltage as the inputs, and then the outputs will also be the either voltage or current. So in this case, we have go to component 3, which is current amplifier. If this subcomponent 2 converts the voltage into current, or maybe it is being converted into subcomponent 3. So the current amplifier will provide power to drive the loudspeaker. So it will amplify the current. And then it goes to components number 4, which is loudspeaker, where it will convert the electrical signals, either current or voltage, into sound, which we can hear here at Y, the output. And if the system has a feedback, so if you look here, it will go to 5, the air through which sounds propagate through the wall, and then the echo from the wall will feed back to the microphone. So this is the whole system of a public address system. Consists of, in this case, 6 subcomponents, which actually it consists more. So for demonstrations or the definitions, so in this case, we only look into 6 subsystems or elements. Okay, and as we can see, each subsystem has an input and an output. So each one, for example, number 1, the input here, the output there. The output of number 1 will be the input of number 2, and then we have output 2, and then Y2 will be the input for 3, and will produce output Y3 here, and so forth. Okay, so this is the whole component of the system. Okay, and then now that we understand the system, let us look into the classification of the system. Okay, some a system, as we look here, signifies a combination or collection of interconnected elements or parts performing certain function. For example, just now, one have to convert the physical signals into electrical signals. Another one, amplifying. Another one is, what else? Provide power. And then another one is converted back electrical into sound, for example. So each components will do or will function certain or give certain effects. A system can be viewed as a process in which input signals are transformed by the system or cause the system to respond in some way, resulting in the signal as output. Just now, input 1 will produce output 1, and this output 1, system 1, will be the input of the system 2. So the elements may be physical. So in this case, sound converted into electrical, or mechanical, maybe a pressure convert into electrical, or non-physical models, for example, like data communication. Okay. So some classification. So in order for us to understand more about a system, there are some classification of systems based on how or what is the behavior or the characteristic of the system. For today's class, we will look into this classification of systems and some examples on this classification. Okay. Yes. The categories, if you look here, there are 4 classification of a system. One is continuous versus discrete, just like before, just like what we learned in the first week on signals. But then now it is into systems. Analog versus digital, static versus dynamic systems, and causal and non-causal systems. Okay, so that static output of static systems depend on present input, and then causal, the output of the causal system is based on the past input of the system. So we'll look into it one by one. Okay, so first of all, let us look at the continuous time and discrete time systems. Okay, a system is called continuous time if its input, in this case xt, xt, t mean times, and output yt may change at any instance of time t. So that's why if you look here, the x is xt to give output yt. So in this, for example, we have a continuous system here. So our input is xt, x with respect to time, then produce y with respect to time. Whereas if you look into the discrete time system, a system that transforms a discrete time input signal, in this case the symbol is xn, n is the sample of time, into a discrete time output signal yn. So a bit different here. So in our case, we'll not look into discrete. Most of our throughout the semester will be on analog or continuous time system. Okay, so the representation is shown in the block diagram here. Okay, so let us look one example here, which is the continuous time system. I think your notes is a bit different, right? So I already have the answer here. So if you saw a blank in your notes, please jot it down somewhere in your notebook. So this is an example of a continuous system for in application of electrical system. In this case, our electrical system consists of resistor and capacitor. Okay, so in this RC circuit, the input is, the input is actually Vs, and the output is actually V1 and V2. I put it V1 and V2, but the diagram shows is Vs and V out, I think. Okay, so please change the notation as well, because previously I used different diagram, but suddenly I realized that the position of R and C is actually a bit different. So the voltage, the output voltage is actually at the capacitor. So if we remember the Ohm's law, in order for us to determine the current I, it is actually Vs minus V, in this case V out, divided by resistor. So that is the current I. And we also know that the current at the capacitor is C dV dt. So in this case, it will be C d VO T dt. Okay, and then if we equate that because current equal to current, so we have this equations. C dV T dV in here is out, so kita punya will be a bit different lah. We go to our board. Okay, so the first current here I, tak ada pula. Oh, B naught. Yes. Our input is Vs, C, and the resistor is R. Okay. And then the current in the capacitor, the same current is C dV dt, C, and in our case d V naught. Okay, so if we equate, this is what we have here, C dV naught T dt equal, so I just rewrite here, C d T, and then we have our okay. If we want to look, because we defined the system previously in terms of input and output, so we write the equation so that we have input output a relationship. So wherever the whatever the V naught, we put it at the left hand side, and then we equate it with our input. So we have so we have here the V naught T D, and then just now the V naught, another one is over R. We simplify here. Where is our C? We simplify here in terms of differential equation. Okay, so 1 over RC T, and then finally we have our input, which is 1 RC V. Okay, so this is our equation for the electrical system RC circuit. Okay. Let me continue with another example. So another example is on automotive system. Okay, I think you learn about force and Newton's second law, which is summation of force equal to mass time acceleration. So in mechanical system, especially if you learn dynamics, you all semua belajar dynamic masa tahun berapa? Belajar dynamic tak? Kelas? Ke physics ke apa? Mana dia pergi? You belajar dynamic masa bila?
Form 5.
Form 5. Apa Newton second law? Summation of force equal to MA. Kalau buat dynamic tu, we have let's say the system, in this case is the automotive system. So we define the forces, and we try to uh, find the summation of that forces. If, for example, like this case, it only consider the force at the x-axis, okay, and then the right hand side is actually on motion. So in this example, this body having a mass of m, and it will move into this direction with acceleration of a. Okay, so if you look at this body itself, in this case the car, so the forces here consist of the forces by this F, okay, as well as the friction. So friction usually opposite direction of the motion. So in this case, the friction is here, and our motion is at the towards the right. Friction usually opposite direction, and there are actually a lot more forces. For example, like weight and normal and, but in this case we look at the x-axis. So this is how we come up with this equation, m, and then we know that a is actually, kalau belajar physics dululah, acceleration equal dv, v stand for voltage, dv dt. So we have here m dv dt equal summation of forces. For example, if we have the right is positive, so we have here Ft minus the friction force rho v. Okay, so we have equation 4 here. And then just like previously, we put that equation into input and output relationship. So we have here, let's say the input is F and the output is the voltage. So we have here, we rewrite the equation. So we have dv t dt plus rho m vt equal 1 over m ft. This equation is actually into we simplified into the differential equations. Okay, so this is equation 5. Previously, we had equation 3, input and output relationship for the RC circuit. And this is the input and output relationship of the car. Okay. So if you look here for both system, for both continuous time system, why it is continuous time? Because T of the T here. Just before, when I said discrete, we have n in terms of n, sample of time. But this continuous time system, it is T. So for the first case, this is on the RC system just now. We take back the equation number 3, so we have this equation, and then go back to automotive example just now, equation number 5, we have this, where in this, the first case, the input is the voltage source, the output is the voltage at capacitor. And for the automotive system, the input is the F here, and the output is V, velocity. So this equation, 3 and 5, later on you will learn about, for example, if you still remember when I talk about the water tank system, and then thermal system. If you go deep into the thermal system, for example, like for mechanical students, they will learn about thermal systems, and then gear system, and a lot of systems. So usually we represent that system into linear differential equation if it is a continuous time system. So these equations are examples of, because we only have first derivatives. So these equations are example of first order linear differential equations of the form, if you can still remember when you learn calculus, dy dt plus ayt equal to bxt, where xt and yt are the input and output respectively, and the a, b are the coefficients. For example, the coefficient for In this case, in mechanical system, in the automotive system, the friction, and then for RC, the resistance, the capacitor. So it will give us the coefficient of A and B. Like this case, the A will be R over C, B will be R over C here. So meaning that this value must be the same. Okay. Okay, so this is the continuous time systems. So far so good, class? Boleh ya?
Okay, doktor.
Okay. So today ni explain sahajalah. Okay, let us move to discrete time system. So discrete time system, instead of T, we have N. N stand for sample of time. Sample, certain sample of time. Later we will look to the definition. So one example of the discrete time system in this slide is the balance in a bank account from month to month is given as, okay, let's say we have a bank account and the balance is given like as in the equation. Okay. Yn, the output, equal to 1.01 yn minus 1 plus xn. Okay, so if we rewrite in terms of input and output system, so in this case, the output is still y, the input is x. So where yn is the balance at the end of the nth month, okay, if you look at the balance of the month of December, so meaning that 12 month, so xn is the net deposit minus withdrawals during nth month. So in this case, we have the interest rate is about 1%. So therefore, we have 1.01 here. 1 point, the plus the interest rate, 1.01 yn minus 1. So it given in terms of numbers instead of time just now. In continuous, we have t. Okay, so if we go back to our automotive system, okay, by sampling the signal with delta second between each successive samples. Sometimes when we do data acquisition of a real-time example, because katakan kita nak kita run sesuatu sistem, katakan engine ke, ataupun kita dapat data yang continuous kan, continuous, but then we want to collect that data, we do sampling. Sampling ni kadang-kadang kita buat sampling every 10 second ataupun kita sample every 1 minute. So that is the sampling lah. Okay, sampling. Sebab kalau kita nak ambil masa setiap second for example, so the data will be huge lah. So in this case kita sample, kita every macam katakan every 20 second satu data masuk dalam kita punya data acquisition and so forth. So by sampling the signal of the automotive with delta second for whatever the sampling time that we choose. Untuk sampling time ni pun dia ada teori dia, ada beberapa research dia come up with the theory what is the best for sampling time, and usually it looks into the kind of system that we look into lah. Katakan in our case we sample for every 5 second. So delta meaning 5 second. So delta is the sampling. Between each successive samples, maknanya every 5 second and then 10 second, 15 second and so forth. The instant t is corresponding to the nth sample. So therefore t kita tu adalah n delta. And then we go back to our equation sebelum ni yang automotive tu tadi. Dan begitu juga kalau kita nak tengok pada RC lah. RC circuit. So instead of we have dVt dt just now, okay, so kita buatkan dia sebagai sample like this. So kalau kita tengok sebelum ni tadi, if you go back to our here, our automotive just now. So kita ada mdv tadi saya punya sistem ni ini electrical, ni kereta tadi So kita ada MdV dt and then kita rewrite ni, sepatutnya ada satu lagi equation ni. It will be, betul ni, this one, sorry. So, saya dah rewrite dia dalam bentuk yang merah, number 5 So dV dt ni kita tukarkan kepada sampel tadi. So we have here Vn minus Vn minus 1. Sebab kita tengok usually bila kita buat derivative tu kita compare dengan the previous previous times punya sampling ataupun value. So Vn minus Vn minus 1 over delta. And then yang lain semua kita convert into sample at that moment. So at that moment is actually Vn. Begitu juga Fn. Tetapi yang kita lihat previous adalah dV tadi, dV dt. So remember kelas bila kita dapat tak keluar sini ni. Okey, lambat. Okey, kalau kita buat usually bila kita buat derivative tu kita tengok current dengan previous kan. Okay, so this is what it means here. Kat sini. And then saya rewritekan semula in terms of simplifying into the discrete. So we have here Vn minus m over m plus rho delta Vn minus 1, so forth. So we have equation number 8. And then if we compare previously yang bank account tadi tu memang dia definitely discrete sebab kita tengok every month 1, 2, 3 dia betul exactly at 1 month satu value, January satu value, February and so forth. That is definitely discrete. And then just now we have our automatic system, kita discretekan dia, so kita dapat this equation number 8. Okay, this equation are examples of first order linear difference equations of the form of Yn, the output of the current state, plus coefficient output previous n minus 1. Maknanya n minus 1 kalau kita lihat bulan 12, yang ini adalah bulan 11, 12 tolak 1 bulan 11. Kalau yang untuk case bank account tadi lah. Kalau untuk case for number 9 ni, for case automotive, we look at now, time sekarang, and then kita plus dengan previous. Sekarang katakan pukul 2 petang, 2 PM. So at least if we said that the sampling is every 1 hour, so 12 pukul 2 tolak 1 meaning pukul 1, something like that. So this equation maknanya daripada from continuous just now, we convert into discrete in the form of this one, this green equations. It is actually first order linear difference equations. So what we can conclude is that continuous, the equation is based on linear apa tadi class? Kalau continuous? Hello? ODE, ordinary differential equations. Kalau discrete selalunya linear difference equations. Okay, and n ni untuk discrete lah. Okay, boleh? So that's why bila kita ingat lagi tak masa kita belajar signal lagi tu, dia tak keluar pula dah. Saya padam balik sebentar. Masa kita belajar signal hari tu, okay. T, and then this one is Yn, this one will be N. Okay, so kalau continuous kita dapat macam ni katakan. For discrete, remember the signal when we learn about signal, dia macam gini because we look at particular n, the sample So N1, 2, katakan month tadi macam for example bank account tu very clear lah. Bulan 1, bulan 2, bulan 3, bulan 4 and so forth. Okay, tetapi yang ni adalah time continuous. Okay, so you will appreciate later on when you go into signal processing. Yeah. Okay. So I continue. So the examples show that many different systems can be described with the same differential equation or difference equation. Hence, they are considered of the same class. Okay, this one usually when you do modeling, ada yang pakai differential equation, ada yang pakai difference equations. So these equations facilitate us to develop a general mathematical model of the system and use the relevant tools in analyzing the behavior of the systems of the same class. For example, like whatever system yang you all ada, kita represent it with the mathematical model. So tak kisahlah apa dia ODE ke ataupun apa linear differential or linear difference. So kita ada apa dalam case ni XT or XN yang kita masukkan dalam sistem, so we know what the behavior of the system is. Okay, so this is the importance of understanding the concept. So sama ada kita nak guna different continuous time or discrete times, so each can be represented by the mathematical model, and then we use any relevance tools lah. Then later towards nanti bila you buat project ke ataupun when you continue your study into higher level of education, master ke PhD ke kan, kita buat modeling, this is where kita masukkan sistem input. Katakan apa tadi, we learn about the step input. Okay, we have the equation, the transfer function of our system, and then we can predict what the output will be. Okay, so note that any model used to describe or analyze the physical system tu refer pada RLC circuit, tadi automotive suspension system, thermal system, water tank system. So this physical system represent an idealization of the system, and thus resulting analysis is usually good as the model itself. So selalunya model ni untuk that particular system lah. That's why kadang-kadang kita whatever yang kita dapat tu tak semestinya sama dengan yang sistem yang lain yang digambarkan with different model, different tools and so forth. However, these idealizations are quite accurate for many real application. For example, like RC circuit and then the automotive system. Okay. Ada soalan so far?
Doctor, what's the difference between differential equation and difference equation?
I am the one who's supposed to ask you. Okay, jadi tadi
Sorry,
kita tengok
Doctor.
kan, sebab saya rasa kebanyakan most of you dealing with this one, right? Differential equation, belajar kan dulu?
I guess so. Yeah, got.
So kita ada, kalau general dia will be D power N, tak silap saya, Y dTn, and then plus D buat tu ya, kalau higher level D2Y kan, dt square, right? And then after Y ke after T, saya pun dah lupa lah ni. Y dt n minus 1 and then plus dot plus Y equal to U pun sama lah sepatutnya, tapi kalau kita nak simplify kan kita kata UT. Okay, so this is depends on N refer to order of your system. For example, kalau you buat macam saya bagi contoh, I give example is on the RC circuit. But then if we have RLC for example, kita ada resistor, kita ada inductor, and then kita ada capacitor. This one later on you will go detail bila you buat control. So bila kita ada macam ini, kita akan define, kita kena derive this system into a mathematical model. Saya tak go detail lah sebab dia ada nanti dalam one of the courses that you will learn how to develop this one into a mathematical model lah, dalam bentuk ODE ni lah. Okay, so usually yours will be on, kalau analog kebanyakannya ordinary differential equation in terms of dy dt ni lah. So you will learn later on how to derive this system RLC system into the ordinary differential equation. So, bila kita adanya ordinary differential equation ni, kita boleh dapatkan transfer function. Transfer function is the output over input, y over u. So bila you ada
How
output over input ni, nanti you akan masukkan dalam sistem, so you will learn the behavior of the system lah. So this one nak dapatkan dia macam mana tu based on go back to the basic lah. For example like RC tadi just now, kita pergi pada Ohm's law, kita pergi pada Kirchhoff's law. For mechanical, we go back to the Newton's law differential equation ni. So this is the differential equation. For discrete is difference equation, like the green one just now. This one is the difference. Difference ni dia tak ada derivative ni dia tak ada. Sebab ni nanti later on you akan masuklah yang ODE ni.
okay, I understand.
This one ni nanti kena akan belajar. Okay, yang ni difference ni more kepada at that particular numbers time. 1, 2, 3 macam saya cakap tadi kan. So this is difference.
Okay.
So here we put that as our.
Pardon? Dia based on previous input. Output. Okay. Apa dia? Ada soalan tadi?
Nothing.
Nothing Just now someone's talking? Tak ada lah. Okay. So in other words, continuous, differential, discrete, difference. Okay. So I move to the next. So this is dia punya theory dia lah, to understand that why we need to understand the continuous and discrete. Usually for mathematical model ni lah. Okay, next one is the analog versus digital system. This is very clear. So analog ni kita kena buat some conversion and so forth. Kalau sistem kita, if our system is digital, it's very clear. Okay, now that we know everything is digital, so digital meaning whether the signal is 0 to 1, and then if it is the value is in between, so that's why kita kena buat some sampling and so forth. Okay. So in a binary, which we will learn also. Okay. So in a binary system, signals being to one of two states lah, 1 or 0. For example, macam katakan saya bagi contoh the pressure ataupun pressure lah, kata piezoelectric Piezoelectric dia bekerja, dia punya konsep is based on pressure. Bila ada pressure, dia akan ada difference in voltage. So akan ada value difference in voltage values lah. Maknanya kalau kita ada sistem ni, mechanical system dia adalah katakan piezo here. Allah aku. So this one, the physical will be pressure. Okay, difference pressure will give difference output in term of voltage. Okay, piezo lah ni, konsep piezoelectric. So pressure kita tahu dia bukan analog lah kan. Dia bukan digital. So mungkin dia ada certain value. That's why we have to do some conversion here. Okay, so anything below this signal will be 0, above this signal will be, let's say pressure kita akan ada between 0 to 5. 0 to 5. So maybe the center is about 2.5. So kalau dia 2.5 and below, it will be 0. 2.5 and above, it will be 1. Okay, so this is the concept of a conversion and so forth lah. So in a binary system, okay, now signal being to one of two states represented by 1 of 0, konsep yang begini, and then the signal level may switch between these levels at discrete time. So that's why we will look into the discrete just now. Discrete tu kita akan tengok satu di sini. Okay. So this is on analog and digital system. Okay. Next one is the static and dynamic system. So apa maksud static, class? Apa maksud dynamic system? Apa maksud static system? Hello?
Yes, Doctor.
Okay, in terms of times, for static system, the current output of the system depends only on the current input. Jadi kalau dalam case ini, if you look at static in terms of time, this is the definition. Okay, dan kalau kita tengok static in terms of masa belajar mechanical ataupun belajar static dulu, the static is defined as summation of forces equal to zero. Maknanya dia berada dalam keadaan equilibrium. Okay, so the output of a static system remain constant if the input does not change. Maknanya dia change at that particular time sahaja. Dia exactly yt equal to xt. Okay, bila kita gerak, baru dia gerak. Macam for example like this gear system. Gear system, you faham konsep gear kan? Faham tak konsep gear? Jadi dia satu ni berpusing, baru yang ni berpusing. Gear system either clockwise or counterclockwise, samalah. Tetapi mungkin dari segi perbezaan di sini because of due to size, this one will will amplify the voltage lah because it has the bigger T's kat sini kan. So adalah konsep gear system ni kalau dalam mechanical. And then the same goes for this one, the dia panggil falling bar. Ataupun nak senang kalau kita ada lampu inilah, maknanya dia akan bergerak, this one, apabila satu lagi tu bergerak. One input link, so bila dia tarik sini, so the output will gerak based on the input. So meaning that the output of static remain constant if the input tak change, dia tak bergerak lah. Tetapi kalau ada gerakan, so the system will move. The same goes in electrical. Example dia bagi adalah transformer. Okay, adanya voltage kat sini, barulah adanya output di sini. So this is called static in this case. Static systems. What about dynamic? Okay, for dynamic, salah spell. Okay, for dynamic system, the present output of the system depends only on the current as well as not only ini tersilap saya tulis ni, not only on the current but also as the previous. So the output of dynamic betul kan So this system bila dynamic dia tak equilibrium lah, maknanya dia akan sentiasa bergerak. So it has a response that is not instantaneously proportional to the input or disturbance that may continue after the input is held constant. So in this case, if you look at the diagram here, the output ni dia banyak faktor yang mempengaruhi. Not only the input, but it also depends on the initial condition. It depends also on the disturbances. So that's why it is a dynamic system. Okay, so difference dia tadi, kalau static, kita tak kacau dia tak gerak lah. Kita tak put dia macam for baling tadi kan. Kita tak tolak dia pun tak gerak. Tetapi dynamic dia akan bergerak sebab dia depends on kadang-kadang initial condition dia, kadang-kadang dia depends also on the disturbances. Okay, for example, like mechanical system, the behavior of mechanical system are usually governed, kita tengok tadi governed by Newton's second law, summation of force equal to ma, motion. So the system that possesses significant mass, inertia, sebab dia ada inertia, dia ada spring. Bila spring tu maknanya dia akan, kalau kita tarik spring ataupun kita kalau ada yang spring kan kita tarik dan dia akan dia gerak-gerak lagi. The same goes inertia punya konsep lah, macam kipas kan. Walaupun kita dah tutup, dia gerak-gerak lagi. So spring and energy dissipation components are driven by force, torque and displacement. So these are all force, torque, displacement are all the mechanical terms lah. Kalau kita dalam electrical, we have RLC, VI and so forth. So dalam mechanical, ada force, ada torque and ada displacement. A car is an example of a dynamic mechanical system. The body and suspension system of a car have dynamic response as it speeds up, slow down or rounds a curve. Jadi bila as kereta ni bergerak, dia ada inertia, dia akan sentiasa kan, kadang-kadang kita brake tu dia slow, dia ada, it still moves. So this is examples of the mechanical dynamic system. Okay. The same for electrical system. The electrical system are usually governed by Kirchhoff's law. The system are concerned with the behavior of three fundamental qualities in electrical: charge, current, and voltage. Electrical systems include circuits with resistive, capacitive, and inductive components excited by voltage or current. So this is example dynamic system of electrical system. Dalam kes ini, TV tuning circuit allow us to select the desired channel, also has a dynamic response. Okay, next one will be last. Kalau ingat tadi classification, I mentioned about 4 types of classification: continuous versus discrete, then analog versus digital. Kita buat juga static versus dynamic, and finally on the causal and non-causal. Masih ingat lagi kita juga, we also discussed this causal and causal in signal just now, previously, week 1 lagi tu. Okay, so we go into the example of non-causal and causal system again, so that you will understand more. So let us look into the first one, non-causal system. Let's say I have input, my input is X and my output is Y. So kita ada satu equation di sini, YT equal to X3T. So please classify this system whether it is causal or non-causal. So how are we going to do that? So kita tengok bila time 0, what is the relationship between the output and the input. Okay, for example, in this case, when T equal to 0, I have that Y0 equal to X0. So the output depends on the current input. And then when I change the T to 1, so apa yang saya dapati di sini, Y1, Y at time 1 equal to X at time 3. Maknanya output dia bergantung kepada forward input. Faham Ingat tak lagi kita define causal and non-causal lagi tu? Masa kita masuk signal. Okay, for causal system, the definition causal signal before ni, the output of causal system is based on the past input. Itu untuk causal, past input of the system. So kalau kita tengok dekat sini, this example, YT equal to X3T. Bila kita tukar sini, when we look at T equal to 1, kita dapati output dia adalah equal to forward input. Therefore, this system is non-causal system. Okay, we look at into another example. So let's say YT equal to X3T, tapi dalam kes ini bila T less than 0. But then bila T more or equal to 0, the Y is changed into YT minus 1. Okay. Same like before, kita tengok bila T equal to 0, sini saya tengok minus 1 dulu, baru kita nampak sebab because condition di sini, satu less than 0, satu above equal or more than 0. So katakan bila less than 0, kita ambil T minus 1. So bila kita tengok di sini, Y minus 1 actually equal to X minus 3. So dia whole meaning that the input, the current output equal to the previous input lah. YT minus 1 equal to X minus 3. Okay. And then bila condition dia equal T equal or more to 0, this one still whole still whole, where Y1 equal to X0. Bila T1, bila T equal to 0, Y0 equal to X minus 1. So for this one, dengan tambah satu condition di sini, this system become a causal system. Causal, non-causal nanti juga sama kita akan apply later dalam towards the end nanti. Bila masuk Fourier and so forth. Okay, so for the time being, I need you to know how to differentiate between the causal and non-causal system. Boleh kelas? Tunggu apa? Nak break ke teruskan je?
Okay. Break.
Okay, 5, take 5. Hello, class.
Hello,
Okay.
Doctor.
Okay, kita sambung balik ya. Continue again. So this is notes e-learning. If you look here, saya biarkan dia kosong lah. So please make sure that you copy the notes that I share you now. Okay, to make sure that you understand the concept of causal and non-causal, can you do the same for example 1 and example 2? So example 1 and example 2. Please check whether it is causal or non-causal. First example is example 1, yt equal to sine t plus 1 times xt minus 1. And then for example 2, yt equal to x exponential of et. Which one is causal and which one is non-causal? So again, definition of causal, the output is depends on the apa tadi definition causal, class?
Example 2.
Ada?
Causal. Don't know.
Ya, apa dia?
Example
Output
2.
of causal is based on the past input. Okay. Kalau macam the first case tadi, sebab dia equal to forward input, so dia adalah non-causal. Okay. So what about example 1? Causal or non-causal? Example 1.
I think non-causal.
Hello? Ada echo tu? Yes? Example 1, saya tulis ini causal. Betul? And example 2 is non-causal. Okay, so this is the, just check when t equal to 0 and t equal to minus 1. Okay, so the conclusion is that for example 1, the output will be this input, because first one, y0 equal to sine 1x minus 1. When t equal to minus 1, y minus 1 equal to sine 0x minus 2. So therefore it is a causal. For the second example, we look at when t equal to 0. Y0 is actually is equal to x1. So the current output equal to the future input. Therefore, the second example, the system is non-causal. Boleh ya?
Sorry, Doctor. If I may ask a question, what's like how? What the times are we supposed to test? For example, when I tested 0, when t equal to 0, it gave me sine 1, which made me think it's non-causal because the output is not given, like the input is not given, sorry. So I
Which
didn't
one?
think of minus 1. Should I
Which
test all the times?
which examples?
In the first example.
The first example. So y0 here. Yeah, you try few conditions. Okay.
Okay, I see.
Okay. And any other question?
No question.
Yang lain-lain? What about others?
Don't have.
Okay, don't have. We move. We move to the next one, which is okay. How do signals and systems are related? Good, because in first week we learn about signals, and this week 3 we learn about systems. As I mentioned earlier, because we know that system consists of components, and then usually we want to look at individual components, and we put into whatever the signals that we look at, and then we want to know the behavior of that particular system or subsystem. So for example, designing a system to restore or enhance a particular signals. So we want to remove high frequency background, for example, in noise. So we need to look into this, what happened when we put the signals into that particular system, or we enhance noisy images from spacecraft. These are some examples of condition. Assume a signal is represented as x equal to dt plus nt, and usually the signal will include the noise as well as, and in this case nt is noise. And also we want to design a system, so therefore we want to design the system in removing how to remove that particular nt. So that's why we need to know the signals as well as the what type of the system that we look into, right? Sama ada dia digital versus analog, or the discrete versus continuous, and so forth. So these are how the signals and systems are related. Okay, let us move towards the interconnections. Now that we know the classification of the system, let us look into interconnection. For example, just now we look into the public address system. So one element is connected into another by series. Ada juga yang feedback. Okay, so in many cases, system or subsystem have to be interconnected to obtain a particular control or regulated activity. For example, tadi daripada sound, kita convert kepada voltage, voltage kepada current, and then current back to the sound. So interconnecting models of components allow us to easily construct large control system models. Okay, analyzing systems that are modeled in a block diagram should be easily done using a scientific computing tool like MATLAB. Later on, when you learn about MATLAB, okay, how to apply this, kita akan belajar sedikit nanti. For example, if you look into the last part of our course, we'll we looking into the analog filter kot. Silap saya analog filter. So analog filter. So for example, filter ni macam saya cakap, for example, examples of how to remove a noise. So we design an analog filter. So in this particular example, like for example, this is our analog filter. Then we have a signal. So how to move that? Designing an analog filter consists of amplifier, resistor, capacitor, so that our signal, our output will be truly the signals only, not the noise. So by doing that, by interconnecting or by looking at a system and then combine and then feed it back. Bila kita dah dapat signal, we want to amplify, for example. So we put into the subsystem number 2. So in this way, it will be easier for us to look at the time response or frequency response of the system. Frequency response later on, second half of the course, you learn about frequency a little bit. Can be obtained after the block diagram is simplified. Simplification means that the several components or blocks described by different transfer functions that make up the complete system have to be algebraically reduced to one transfer function to represent the system. Okay, the mathematical reduction is done based on the rules of control theory. Okay. For example, macam tadi kita ada, for example, this one, once we convert that system, then we amplify. Katakan system 1 adalah conversion from physical system from mechanical into electrical, for example, and then we amplify. Okay. So this connection is called series or cascade interconnection. Okay, but sometimes we have input, but one goes to the series and then another one goes to the parallel. B dulu, sorry, saya terus C. Parallel first. One signal here and one signal there, and then you combine to give one output. That one is parallel interconnect. And then C is series parallel interconnect, because we have 1 and 2 is series, and then 3 is parallel. And then last one is the feedback interconnection. Feedback is especially you will deal a lot when you go into control theory. Okay, so let us look one by one. Interconnection of a system, series or cascade. The output of system 1 is the input of system 2. And the overall system transform and input by processing is this one, input from system 1, the output will be from system 2. So ini kita panggil sebagai series interconnection. Okay, so the output Y will be system 1 times system 2 times input. Okay. Parallel. Okay, parallel we have both X goes into system 1, goes into system 2. So in this case, kita ada output will be X. For example, this one X system 1 plus X system 2 to give our output. Ataupun if you simplify, system 1 plus system 2 time input. Okay. So that is parallel. What about the parallel series? Okay, so first kita timeskan dulu, and then we plus system 3 all together times input. Ataupun if we go one by one, this one X system 1 times system 2, X system 3, and then all together plus. And then finally, sayang ni saya dah ada jawapan. Saya nak you all tengok. So what about the final one, the feedback system? How do you describe the equation? So let's say input is X, output is Y, and then system 1 dia punya description is GS, system 2 description dia adalah HS. So what will the equation for Y be? Anyone? Cempok saya tadi. Okay. Okay. So we have just now input dia tadi X. And then the first one, it says GS, right? Output. Yang di bawah di sini is H. Summation plus. Okay, so plus. So bagaimana dia punya equation? Anyone?
I think, sorry, the echo.
YS will be, kalau kita tengok direct di sini lah, YS will be GS
times XS
ES, right?
plus
Times lah. Times dia bukan plus kat sini. So what is ES? Based on the diagram here?
YS over GS.
Yeah. The ES plus the ES equal to okay, XS plus HS
Tuhan.
YS. Okay. So the output. Yes. And then we put that into this equation. So kita ada YS GS times ES kita this one XS plus HS by S. Okay, so rewrite, usually when we rewrite in terms of output equal input. Okay, so nanti ni kena buat ke sini dan sebagainya lah. Okay, so mana tadi? This one the output system 1 input plus output times system 2.
Dr. YS just now is what?
Pardon?
YS.
YS is the output.
No, the equation.
GS ini, sini system 1 saya kata GS, system 2 HS. Okay. YS ini adalah ES dan GS. And then YS, this one, kita dapat daripada sini lah. ES ni kita masukkan this one.
Oh.
Okay. So, this is how our system looks like. Okay. Nanti control akan learn more. Okay. So, I continue Ada few minutes lagi ni. So, I think I stop sampai properties ni kita buat Kamis lah, and then saya nak tengok you punya time transformation sekejap. Okay, so this is on interconnection, and then this is examples how we have the feedback in application of electrical circuit. This one kalau kita tengok adalah parallel. We have the input here is the current, and then we have a capacitor, and then we have a resistor. So for each components here, we have I1 is actually current at the capacitor, and then I2 current flows through this resistor, and then all these are parallels with the same voltage. Okay, so guna current law tu kita dapat I1, where is our I1, equal to IT minus I2T, and then it is actually a feedback interconnection, and then if we rewrite, kita akan dapat this one. Okay, to show you the connection and the application. Okay, the voltage is actually current 1 times this capacitor here punya voltage. Okay, sebab voltage di sini semua sama. Okay, this is examples how we define the system, and then kita tengoklah dia series, parallels and so forth. Okay, and then the next one will be on the basic property, because this basic property kita nak tengok dia punya definitions, especially all this lah, semua ni kita kena tengok inverse, invertibility, time variance and linearity. Lastly nanti kita next week we will look into details on the LTI, linear time invariant system. Okay, kita stop di sini dulu. Saya pergi kepada go to our e-learning. Just want to check the exercise that I ask you to do. Okay, berapa orang yang buat ni? I have attendance today is, saya belum ambil gambar. Okay. Where is my attendance? Kalau tengok attendance ni, we have 24. Right? Macam mana boleh ada 24? Narai nama student, I think. 25. Oh, 28. Okay. So ada ramai yang tambah add ke? Okay, so tengok balik tadi.
Doctor, can you add student in the learning?
Class attendance semua clock in. Tak clock in pun ada 17 je kat sini. Please, yang lain tu.
Doctor, can you add student?
Because at the end of the semester, I have to submit all this attendance.
Doctor, I think Danish want to ask Doctor regarding the e-learning. Did
Okay.
Prof can add student into the e-learning or need to wait the office to add?
I don't know how to add. Okay, if you based on my participant kat sini ada 28 already. So ada siapa lagi yang tak masuk ke?
The Danish. Last time he mentioned about the e-learning problem.
Oh, Dennis still cannot enter. Okay, let's see. Let me. Dennis ada sekarang ke?
Ada Doctor. Tadi is my mic okay?
Okay, I try add.
Okay.
I don't know how to add lah, Dennis. Sorry.
I think you need to email to the office again, which mentioned you need to get into the e-learning as soon as possible because I having this problem before.
Okay, Danish, why don't you email to me? You have my email address, right? Robia Ahmad, and then I forward to office. Boleh?
But Doctor, the problem is the registration of the subject is the problem.
Oh.
Not the e-learning. The registration of the subject, because I want to regrade the subject and the system is not ready yet, the office said. That's why I can't register.
So that one, in that case, I cannot do anything lah. Boleh ke?
It's okay. I can still wait.
You can still wait because
Alright.
I still put the notes in my website also. So if you cannot get access to e-learning, you can access the notes to my personal website. I shared before kan dekat dalam WhatsApp group tu.
Yes, okay, Doctor. Thank you.
Use that link, you use that link, you can also get or download the notes. Okay, boleh? Tapi mungkin Danish tak boleh.
About this problem.
Jamboard you still go, you still can Jamboard pula apa? Padlet you still can go to Padlet because whatever that you write to Padlet, for example macam masuk je dalam ni saya rasa Padlet. Kalau you buat di sini, this one I just link to my Padlet. So if you do here, ada Danish ada buat sini tak? Danish?
Tak ada lagi. I buat dekat buku je. I tak post in the Padlet.
Masuk kat sini je, nanti kita akan tengok jugalah. Kita boleh tengok sama-sama. Sini pun tak semua buat lagi ni. First one, the second one. Second one, not many. Any question so far on the time transformation and even and odd ni? Dia tak sempat tengok satu-satu tadi. Saya nampak seorang. I don't think I have signals like this, Nurin. My question is satu saja rasanya. Kenapa ada unit ni? Is Nurin here?
Yes, Doctor.
Nurin, saya punya signal satu sahaja. Where is my question?
Mana?
Ni ada. Simple je question dia. This sotos X 0.2 kita apa? Scalekan dia. 0.2 and then plus 5. This one ada scaling, ada in reversal, ada shift. So tak ada mana tadi Nurin buat ada apa?
Oh, that one. Doktor, sebelah ada.
Sebelah. Oh ni
Sebelah tu, sebelah tu. Yang atas tu.
Oh ni nota je.
Yang itu kan doktor bagi 2 exercise kan. Satu lagi yang on event tu.
Tapi mana termasuk this one
Yes.
Oh, okay. Okay. Macam-macam jawapan saya dapat ni. Okay. Is it okay yang time transformation? What shall we have this one? Plus 5 meaning dia move kepada this side, left, betul? And then kita 0.2 maknanya nanti dia akan jadi kembang So how shall the signal looks like? The share the figures looks like. Kalau kita tengok dekat sini, sini Jamboard, ada few minutes lagi ni. Nanti kan saya dah bagi jawapan, yang lain tak buat, tak apa. Anyone? Ramai tak buat lagi ni. 1, 2, 3, 4, 8 orang. Okay, saya tak mau bagi jawapan. So, I still open. Please, siapa yang tak jawab lagi, please put your solution here at the Padlet. Kalau tak ada Padlet, I think I also share the link Padlet dekat WhatsApp lah.
Doctor, which example?
Hmm?
The exercise. Which example?
Example,
I mean the one that need to submit.
this one lah, stay because not many. Sebab saya nak discuss tapi ramai tak jawab lagi ni kan.
Wait, is based on the lecture notes, right?
Yes.
Yeah. So which example in lecture note?
When we talk about times transformation,
Time.
the notes on time transformation where we have time shift, time reversal, and
Oh,
time
it's
scaling.
all the example lah.
Yes.
Oh.
So in the class, first we talk about time shift, and then we talk about time reversal, and then we talk about time scaling. And then last week saya ada bagi summary ya. Remember this one? Saya buka Jamboard saya balik. Saya nak pergi Jamboard macam mana So last week kita punya kelas yang mana? 25th yang saya summarize kan tu. This one. Cuma nampak ke? Nampak kelas? Jamboard ni?
Nampak.
Yang saya summarize tu, this one. Remember last time I summarize time shift, time reversal, and then kita juga ada kita reverse dulu and then kita shift. This one is shift plus reversal. This one reversal plus shift. And then we also discuss about scaling. Yeah. So
But
exercise yang saya bagi combination of all.
The even and odd function is the exercise. There is 2 exercise in the lecture note.
Yeah.
Is it
We also
the
discuss about we also discuss about odd and even. Remember odd and even? Kalau even ni xt plus x minus t divided by 2. If odd is xt minus x in minus t divided by 2. Yeah, this one, odd and even. Okay, we also discuss about odd and even. Betul-betul risau saya pasal ni ya. Okay, this one. Yeah, we also look into examples.
I cannot find it in the slides.
In the slide ada. Tak ada ke? Yang summary ni memang tak ada lah. Yang dekat Jamboard ni memang tak ada yang ni. Because I just summarize. Tapi nota for scaling, reversal and shift all in the lecture notes. Here. This one.
Oh,
Ada.
okay.
This one ke? Chapter 1, yes. Chapter 1 on unit function and time response. First week tu on introduction to signal.